Tyler and Nico coming at you live with how to solve vectors. So let's jump right into this. We got right here, this is a vector in standard position. Pretty simple, starts at the origin, as you can see 0, 0. This is the direction of the vector, which is 45 degrees. And this is the end of the vector, and this hole right here, the length of this is called the magnitude of the vector. So right here we have one drawn up, and we're going to go ahead and solve for magnitude and direction. So to solve for magnitude, you want to use distance formula. So plug in distance formula, x or y2 minus y1 and x2 minus x1. So you plug that in, you get 6 squared plus 7 squared, and that equals 36 plus 49, 85. Root of that, which is, plug that into your calculator, should be about 9.2. So 9.2, and that's how you solve for magnitude. And then to solve for direction, we have to go back into trig. I know no one likes trig, but it's pretty useful, so I guess we're going to have to use it this time. So to set this up for trig is pretty simple. Basically all you have to do is you have to find the tangent of this angle P, right? So let's make this into a right triangle, and you want to find this. So P, we're going to do tangent of P is equal to y2, which is, y2, which is 8 minus okay, so to find direction, you have to find the tangent of this angle P. So we make this into a right triangle, so it's trig, That's how you find everything that has to do with trig. So then you have to do this. You have to go find x2 or y2, which is 2, minus 8 over negative 4, which is this one right here. That's x2 minus 3. And once you get that, you get negative 6 over negative 7, which reduces to 6 over 7. So now you have to find the tangent, or now that you know the tangent of negative 1 is 6 over 7. So you plug that into your calculator, and you should, once you have it all plugged in, so let me do this real quick, plug this in, and you get 40.6. Now I know that you think you're done there, and that's the direction, but you have to remember that because this basically right here is just a horizontal line, you have to add that to 180 to find this whole measure. So we have to get that plus 180, which is equal to 220.6, and that is the direction of this vector. Okay, and then so we're also going to do component form. Component form is also really simple. All you have to do is do change in x, change in y. So let's do x2, or in this case, negative 4, minus x1, which is 3, and then y2, which is 2 minus 8. So then you get negative 7, negative 6, and that is component form of this vector. And then so basically the whole reason you want to know all this is so when you have shapes for tessellations and dilations and they have vectors, it's easier for you to solve. It also helps you with equal vectors. Equal vectors are vectors that have both the same magnitude and direction. And then there's also parallel vectors, which will help you for 3D shapes, like this. That's a square, cube, something like that. And basically for a vector to be parallel, it just has to have the same direction, so the same angle. And yeah, that's pretty much how you solve for vectors.
That was pretty interesting.